Thank you all for joining us. So here we are for DIME's Virtual Journal Club for June. Topic of today's discussion is how the V3 framework might be applied to wearable dosimeters and light loggers. My name is Jessie Backer. I'm a program director here at DIME, and it's my pleasure to introduce and welcome Dr. Manuel Spitschan, assistant professor and research group leader, to lead today's discussion. So just before we jump in, a bit more about Manuel. Dr. Spitschan studied psychology at the University of St Andrews in Scotland and did his PhD at the University of Pennsylvania. After completing postdocs at both Stanford and Oxford, he's now assistant professor of chronobiology and health at the Technical University of Munich in Germany, and a Max Planck research group leader at the Max Planck Institute for Biological Cybernetics. His main research interest is how light affects human physiology and behavior. I'd also like to acknowledge our co-authors on the paper that we'll be discussing today, which is available in full text at the journal Digital Health. Karin Smulders, Eindhoven University of Technology, Ben Vandendriech from Byteflies, as well as Case Western Reserve University, Renee Bent at Edge Analytics, Isaac Rodriguez Chavez, who at that time was at ICON, and Celine Vedder, who at that time was at the University of Colorado Boulder. So with that, I will hand it over to Manuel. Welcome, thank you.
Thank you so much. I think you could go to the next slide. Perfect, great, excellent. Thank you so much for the invitation. Very excited to be here and also very excited to talk about this work, which really is trying to apply this V3 framework to one thing that I, as a chronobiologist and visual neuroscientist, care a lot about, and that is light exposure and how we can measure it and relate it to health outcomes. And so in case you came to this talk or this journal club from a light exposure perspective or a dosimetry perspective, it might just be useful to review what the V3 framework does. Basically, the idea here is to devise, or the whole idea of the V3 framework is to provide a framework in which various aspects of what is summarized under biometric monitoring technology could be evaluated. And there's generally three steps that are kind of sandwiched, I suppose, between making prototypes or designing a product and then thinking about its clinical use, its clinical utility. And so when you're looking at the V3 framework, which was developed by the Digital Medicine Society and is now applied to various types of wearables, we have verification, we have analytical validation, and we have clinical validation. This is from the original V3 paper. I'm sure we can put the references to this also in the chat, and if you don't already know them. And so in the verification stage, we're looking at evaluating and demonstrating the performance of a sensor against a specific set of criteria, right? Thinking about, well, what is this thing really measuring? In the analytical validation step, this is looking at the performance of an algorithm or a set of algorithms, and the idea then basically to relate that algorithm to specific metrics that might be of relevance. And typically these are physiological or behavioral metrics. So we have verification, analytical validation, and the clinical validation. And really in the clinical validation step, we're taking the biometric monitoring technology and asking, does it in some way relate to clinical, biological, physical, functional state or experience outcomes. And so this is, of course, a generic framework, right, by which we can use a evaluated technology and think about, how do we realize any of these steps in a given technology? And so you can think about, for example, sleep trackers as one example, but also any other physiological wearable measurement device, right, blood pressure, etc. And so what we did in this work was to look at light loggers. And next slide, please. Hopefully the slide can change now. Perfect, excellent. So in this framework, within the V3 framework, of course, you have to identify in a way, what is the technology we're looking at. We're specifically interested in light logging and dosimetry. And so if you haven't thought about light exposure, let me walk you through how we consider or we think about this kind of question or this kind of problem. Of course, we as humans are exposed to a number of light sources throughout the day, and this is not only light sources, but also illuminated scenes. So right now, as I'm sitting here in front of my my monitor, I have, of course, my monitor that gives me light. I might have also the windows that I'm facing here, but also if I had light on, there would be a lot of light sources, making it quite complicated to know what is the light that is actually reaching my eye. And when you're thinking about the physical characterization of this light, there's really 3 dimensions to it. We have a spectrum of light per specific part of space with the spatial dimension. And of course, because I'm moving my head and my eyes, that light that is reaching my eye is changing over time as well. And so we consider this as kind of the totality of ocular light exposure. We called a similar term the spectral diet, right? So this idea that we have different components of light that kind of we are exposed to. And now this is where it's really becomes interesting. So if you look at the bottom part of this kind of pipeline, the biological quantity that we're interested in is the retinal irradiance. How much light reaches the retina? Now, the retina is the component in the eye that, is taking the photons and converting it into neural signals, and then through various physiological processes impacts our health. And so, one of the major outcomes that we, for example, are interested in is the impact of light exposure at the wrong time on our circadian system, on circadian physiology, and our sleep. And so we know, for example, that light exposure at the wrong time is associated with various negative health outcomes. We can measure this in the laboratory. But of course, the more interesting thing is really to think about the variability of light in the real world. And this is why we have to think about the ocular light exposure and then the following retinal irradiance really as the quantity that's of relevance here. Now, unfortunately, for us, the retinal irradiance is unobservable because only the retina, in a way, can measure the light that is hitting it. And so what we typically do then is we capture the light exposure near the cornea, on the corneal plane, or approximately in the corneal plane, using a variety of sensors. We call these light loggers or dosimeters that give us the ability to measure, for example, every 10 seconds, the light exposure that is reaching the sensor. We can then summarize this. So out of these measurements then come personalized light exposure, and we can summarize the light exposure using some summary metrics. So this could be, for example, just as a simple metric, could be the maximum light exposure that you have received throughout the day. But we now have also moved away from very simple metrics. There's now more complicated ones. For example, what is the regularity of light exposure? So a group at Monash University developed the Light Regularity Index, which kind of tells us how regular is the light exposure. And then from these summary metrics, we then try to do inference, right? We try to relate the summary metrics to some of these health outcomes. And of course, this requires measurement over time sometimes also relatively large samples. But this is broadly kind of what we consider the pipeline, right? We end up with capturing light exposure in some way and then relating it to some outcome that we care about, whether it's sleep quality, BMI in some studies as well. And basically the final step here is really where we have the ability to test hypotheses linking light exposure with some health outcome. Now, let's apply this to the V3 framework. So I mentioned, next slide, please. I mentioned 3 steps. We have the verification, we have the analytical validation, and the clinical validation. And I just want to walk us through how we conceived of light loggers and dosimeters as subjected to this framework, and specifically to the verification stage. The verification stage here really is about the sensors and the devices that measure light exposure. And so there's a couple of things that we want to know if we are using these light loggers, the devices that capture light exposure. And we've listed them here. This is largely based on documents that were developed for other devices that also capture light by the International Commission on Illumination, the CIE. So one thing that we want to know is the spectral properties, right? So spectrum is one of the things that we care about. How is the device, how is the sensor capturing light of different wavelengths? Another question is, what is the UV and infrared response, right? So do the sensors either have a UV or IR sensor, or does light in the UV and in the IR modify the light that we measure in the visible range, right? So this is typically shouldn't happen, but depending on what the sensors are and their spectral sensitivity, you might have some out of band responses. The directional response tells us how much light is entering the sensor, is captured by the sensor from different directions. And this is really a way to think about the, how's light integrated by these devices. And I'll just walk through the other one. So linearity is, if you're doubling or you're multiplying the input light intensity by 10, is the output that is measured by the device also multiplied by that same factor. Fatigue is something that we so far haven't seen in light sensors, but something that is listed typically in these documents. That is, if you're exposing a sensor to very bright light for a very long time, does that then change subsequent measurements? I think you can imagine some processes that would make this happen if you saturate the chip or whatever. Dependence on temperature and humidity is very important, in particular when you're looking at low range or the low end of light exposure. And the reason for this is, you have more thermal noise at that end. So something to think about when you're trying to capture the light that is typically in a bedroom. The response to modulated light, right? So we are typically exposed to constant light in some way, but LED and other technology flickers light at an imperceivable level. And sometimes these sensors cannot really capture this well. And so this is something, of course, we also think about. And then what we call the range change. If you're in a dim room and and this happens a lot to us in the lab, you're in a dim room and you suddenly step out into very bright light, of course, the dynamic range of the sensor suddenly has to be quite different. And so this is really what we consider here the verification stage, right? We're doing characterizations and calibrations of the sensors. Next slide, please. Well, we thought, so when we worked on this project, we were kind of thinking about different ways to apply V3 to this kind of pipeline. And we thought, well, what about the analytical validation, right? So the analytical validation here is the next step in this pipeline. And that is really trying to figure out, are we capturing the right things, right? So you can calibrate the sensor using relatively straightforward calibration techniques where you expose them to very well-controlled light sources. But the ultimate thing is, well, what about this if we bring it to the real world, right? So instead of exposing it to a well-defined light source at the end of an integrating sphere, what happens when we do these measurements in real scenes? And so the key thing to realize here is that the light that also we're getting is never, the light that is just emitted from a light source, right? Unless you're standing in front of a light bulb or some device that we typically have in the lab, we don't have, unadulterated spectra in a way. It's always light that is bouncing off surfaces that have different reflectances, thereby modifying how much light gets reflected. And so in the analytical validation step, what we're really relating here is, the types of light sources that we could be exposed to with the personalized light exposure that we have recorded in a given trial. And so this is, for example, a check, a validation to make sure that, if we know someone has been outside for a whole day, then this should be, of course, be reflected in the light levels that are reported by the sensor. Similarly, you could put people in a very dim light, and of course, you would expect the opposite to take place. And so we really think about this analytical validation step as one where we take the calibrations and the characterizations from the sensors, from the devices, and ask, well, now ask about, well, what about these light exposures in the real world that we might be exposed to? Next slide. Finally, clinical validation is really where we're looking at this last stage, right? Where we take the summary metrics from light exposure, from the light exposure time courses, from the light exposure patterns, and relate them with health outcomes. So here, the real question is, if I had a device that said, this is the right way of summarizing light exposure, then of course you want to make sure that this metric that you have selected correlates with something in the real world, right? So we have seen some very elegant studies in the literature looking at, the relationship between sleep quality, for example, and light exposure. There's some nice work coming out of the University of Manchester, led by Altok Didikoglu, who's also on the call. Very happy to see him here, looking at the relationship between sleep quality and light exposure patterns over some time. And so the clinical validation step is really relating these light exposure metrics and selecting them to be relevant for some health outcome that we care about. And so This is, of course, one way of thinking about this problem of dosimetry. One problem or one way of thinking about the verification and validation of light loggers and dosimeters. And I think it offers a way to really, test hypotheses about, the relationship between light exposure and health outcomes. Of course, now, if you are in this field, if you come from a light exposure and light logging background, you will know that there has been kind of an explosion of these devices recently. And at present, there's a lot of opportunity, I think, in a way to, push forward how professional we are in validating, characterizing and verifying these sensors and evaluating them broadly, right? So I can see that there's probably a lot more, a lot that's going to happen in the next couple of years, even more, to really make light sensors and light loggers not only smaller, but also, relate them then to health outcomes in a clinical kind of fashion. Next slide. Finally, I want to highlight some of the current and future challenges that we posed really in this paper. The first one is, to what extent corneal light exposure is a physiologically relevant quantity? And there's really two components to it. The first one is, do we really need to measure light at the level of the cornea? If you're exposing, so the cornea is, of course, at the eye level, is it enough maybe to have a sensor that's attached around your neck, right? Is that enough of information to do some of these clinical validation steps? The other aspect that, of course, is important here is typically these sensors integrate over space, right? So they are discarding information about specific pixels. And as a consequence, you're losing a lot of spatial information. If you are, and so if you're doing this, you can think about some cases where you have the light sensor measuring two extremely different scenes, but reporting the same light exposure value. And that's, of course, a little bit of a challenge, I think, when we're thinking about the biological mechanisms, because we're throwing away all this information about how light is spread out in space in front of us. A second key point is what the usability and acceptability of dosimeters is and light loggers, right? Some devices are not really acceptable because they're too big, or they might be in the wrong plane. And in particular, when it comes to something that's in someone's face, right, there's two components of acceptability. The first one is it acceptable for you as a wearer? And the other question is it acceptable for you as someone who sees it, right? Because you might be worried about privacy concerns. Is it a camera, etc.? We just ran a study on undergraduate students, this is a study that we completed about a year and a half ago. We've just published it, looking at undergraduate students in Oxford, UK, and we found that, for some of these dosimeters that are attached to glasses, the acceptability and usability is relatively low, but they provide very high quality information. Of course, this is something we can think of as a trade-off. Either you have high quality data, or you have something that is kind of so small that you don't really notice that you're wearing it, or it integrates well into everyday life. But it's very hard to have both, I think, in a way. Finally, or not finally, the third point that we mentioned here is, well, which are the metrics really to summarize light exposure that we should use? There was just a paper that came out in Lighting Research and Technology that has looked at systematically the types of metrics that we could work with. This is work led by Stefan Hartmeier. And I think it's a fascinating question, right? What possible metrics are there, and how do we summarize these time courses? Finally, we have comparability of data from different groups and populations, right? So we might have light exposure patterns that are vastly different, of course. You imagine shift workers versus regular day workers. Of course, their light exposure patterns will be different. I expect also you might see a tiny difference if you have a dog, right? I as a dog owner myself, I do expect that dog ownership changes a little bit, how much light exposure you get in the morning and throughout the day. And then finally, I think this is an important one. How do we know, right, when someone has taken off the light logger? And this is, of course, tough, right? We can rely on people to report this, but there's also inertial sensors that could give us this information. More broadly, this opens up the question of, well, how should we do quality control with this? If we have the light logger or a given device, a BioMet, giving us some information, how trustworthy is it? And so these are some of the current and future challenges we thought of. We're currently working on in the CIE and the International Commission on Illumination as a technical committee on formalizing some of these ideas about calibration, so more on the verification step. Yeah, so we're very, very excited about this kind of work. And of course, I'm very excited also to, yeah, launch into the discussion. And thank you.
Thank you so much, Manuel. I learn a lot from you every time we speak. I'm just going to open us up now to the Q&A portion of today's discussion. Thank you also for bearing with me during the technical glitch. One of these days, I'm going to get through a journal club with no technical problems. So to everyone on the call today, please do feel free to add your questions to the meeting chat. But just to get us started, Manuel, you mentioned this a little bit, and I just want to circle back to it. What are some of the concerns regarding privacy of light loggers? So, you know, for example, could light exposure in any way be considered sensitive medical data? And do you have some ideas about how that should be handled?
Yeah, I mean, I think there's really two dimensions to this. I think the first one is, you know, do we consider light exposure as personal health data, right? Is it personal health data and to what extent? And I think you would want to believe that that is the case if you, you know, if you can demonstrate that, you know, people with bad light exposure or inappropriate light exposure, whatever that means, right? It's kind of a hypothetical term for now, have some negative health outcomes, right? I think this is, I mean, not unlike physical activity, right? If you're thinking about, well, if I know you only had 20 steps a day, you know, and that probably has some impact on your general health. Of course, this is something I think one would have to carefully think about. Is, you know, getting good light exposure, and again, whatever that good means, appropriate light exposure. If that is associated with good health outcomes, then of course we should treat it as such. It makes it quite tough, right? Because the ultimate question, though, is if you had two traces of light exposure, two time courses, those then, you know, can you identify an individual with this, right? And I think in many cases you probably cannot, because you just have an overall intensity. And so I think there's a lot more analytical work that I think we'll have to do to see, well, how different really are individuals? Can we distinguish between different individuals? So I think there's a lot more work I think that we could do. I think the other dimension of this is, of course, what I mentioned about the, you know, it might seem to people like you're measuring or you're capturing some camera image of them, because it is a device that you're kind of pointing out in the world. And so there might be the suspicion that it's kind of intrusive. And of course, you know, I think the smaller the thing gets, the easier it is. But, you know, I think there might still be this lingering worry by someone. Oh, I feel I'm being surveilled because you have, you know, I'm talking to someone who has one of these light loggers worn on their glasses.
Is that something that your study participants have questioned, or has that become an issue with people enrolling in studies?
Yeah, so I had two, I think in two instances. I think in the study that we ran on usability and acceptability, this was a common concern, right? It was too big, I think, the device for it to be invisible in a sense. We also did a trial with sort of an informal pilot where exactly we had the same thing where, you know, it's just if you're wearing glasses and you have a thing attached to your glasses, it will stand out. And I think there's something about the face in particular that just makes anything that's odd or attached to the face be very, very salient, right? So we've definitely had a feedback from participants that, you know, they received negative feedback from others.
Right. So I guess in that respect, it's similar to some BioMeTs that include an audio signal, that even though speech may not be recorded, there is still that potential concern from participants as well as others who they interact with. Can you talk through some of the advantages, or indeed the disadvantages, of recording spectral information rather than distilled or simplified information like a luminance?
Yeah, so I mean, I think you can think about these light loggers as, I mean, depending on the technology that is being used, they either capture quantities that are already kind of put into a form that is meaningful for us humans. And so that includes, for example, illuminance or melanopic irradiance or melanopic equivalent daylight illuminance. And ultimately, I think this helps us really assess what could be the biological effects of a given light exposure. What it doesn't help us with is identifying what types of light sources people were exposed to. So you'd need additional information for this, right? So in a way, you think about the spectrum of light having depending on how many channels you have, say 20 or 40, 50 dimensions, this is distilled into one if you just have illuminance. And if you had the full spectrum, what you could, for example, uniquely say is, well, this is a daylight spectrum, or, oh, look, these people spend a lot of time in fluorescent lighting. Maybe they should talk to their, office health and safety people and get retrofitted lights or something like this, right? So I think the spectral information could provide some benefits to identify what situations people are in.
And from a kind of practicality or logistical standpoint, are there issues with things like data capacity or battery life with recording that additional spectral information?
Yeah, I mean, I think this is, I think, a good question, right? I think you always have a trade-off of storage, battery life, sampling resolution, and what information you need. I think there is probably some sweet spot that I don't think we found. And I think this is part of it, right? So in some situations, it might be very useful to have spectral information. Sometimes it's not that useful. And so it really depends on the case. But this is for sure something that one would have to think about quite carefully is, if you're collecting spectral information, do you have a plan for it? What are you going to do with it? I think the spectrum is always the most complete representation. But if that means that you lose flexibility in terms of how long you could record, maybe it's just sufficient to have illuminance as a metric, or melanopic irradiance.
So typically, when we think about BioMeTs or biometric monitoring technologies, they're developed and used to estimate some kind of behavioral or physiological function, within the body, whereas light exposure from the outside is kind of a different way of thinking about it. Can you talk us through, Dr. Spitzan, some of the clinical applications, maybe in your own work or of others?
Yeah, so I mean, I think there's a few areas that I think are where I think we can definitely use this technology. And I think the first one is the examples that I mentioned. There's a clear link and a very well-established pathway that goes from light exposure to the circadian system. So cells in the eye receive information and convert that basically to a signal to our circadian pacemaker to say, it's day now, or now it's night. And we call this process circadian entrainment. And we know that the circadian system, the circadian clock, can be upset by light exposure at the wrong time. So if you expose yourself to a very bright light in the evening, we know that this shifts the circadian clock around, even though it really shouldn't, right? The flip side of this, of course, is that you could use this to, for example, alleviate symptoms of jet lag, try to have adjustment of light exposure of the circadian clock through targeted and timed light exposure. And so we know that circadian disruption, so the disruption of the circadian clock, has lots of negative influences, both on metabolic, cardiovascular, and also mental health. And so, of course, that means that, getting the right light exposure at the right time is really key to having good circadian entrainment. There's another component, and I think this is something that, we think about more in the context of clinical trials, and that is, so you can also imagine light loggers as being a compliance instrument, or an instrument to measure the actual exposure someone got in a clinical trial. So you imagine you have two groups of people in a clinical trial. One gets assigned a daylight condition and one gets assigned a artificial light condition, or some other variant of this. Of course, you want to make sure that the light exposure people got in the two groups were actually different. And so you can see in the clinical space, the light exposure, in particular for trials that look at light as an intervention, this could be of immense importance, right? To be able to accurately track the light exposure people get. And then moving on from this, you can also imagine, well, I mean, some people think that light really is a therapeutic agent, right? And I think in certain studies or certain conditions, you might see, light therapy as something that can be used to treat seasonal affective disorder. And of course, there you can imagine if you prescribe light therapy, you as a clinician might also want to know, well, did people follow the regimen that you prescribed, right? So there's lots of kind of little ways that light exposure could be related to health and clinical outcomes. And it's not just, I think we, of course, as chronobiologists have an interest in this, but I think you can also imagine it as a more general clinical tool. I think the other side of this is, of course, because we know that light exposure impacts sleep and circadian physiology. You could think about light exposure as a confounder, right, that you might want to measure in other studies, right? So if you care about, for example, are people sleeping well, and you tell one group, well, you should exercise outside, and the other group isn't exercising at all, there's two things that change. So you could use the light exposure measurements as something that you can then discount in your statistical analysis.
Oh, interesting. So are you starting to see more and more the application of these sensors outside of kind of circadian and sleep research?
I think so. I mean, I think there's lots of opportunities. I think there is, I think circadian science has matured, I think, in the last decade or so, in the sense that there's a lot more mainstream thinking about this, lots of kind of big pieces that were published in lots of medical journals. And I mean, I think we see the circadian clock as such a powerful physiological process that it nearly affects, most other physiological processes. And yeah, I mean, I think there's a big opportunity here for light loggers, being integrated in other devices of this sort.
To those online, please do feel free to add your questions into the chat box. I'll read them out when we get them, but otherwise I'm just going to keep plowing on through my own questions. It's a really fascinating topic. Dr. Spichchen, where do you see light loggers going or developing, especially in the clinical space within the next 3, 5, 10 years?
Yeah, I mean, I think it's sort of, I think there's one thing that definitely needs to happen, and I think that is miniaturization, right? So I think we have devices now that are, pretty good. I think they're very well suited for research studies, but I think really to make them, make light exposure measurements, a lot more accessible, and yeah, a lot more widespread. Of course, we need to do a clear, there's a clear drive, I think, to making them much smaller, right? And I think there is technology that has been developed in this, but I think to me, this is really a technology development more than a clinical development kind of thing. Of course, there's a lot more that, I think goes in the direction of, I think sensitive, basically making people more sensitive to these questions of light exposure, right? So I think there is also, a key piece of the puzzle is understanding what is good light exposure and how to communicate it, right? And I think, to me at least, this is these are the two, kind of areas. One is good communication, good messaging, and the other one is more technology development to make it smaller.
So has the technology improved in the last few years to give you confidence that it will continue in that direction and become smaller, more user-friendly?
Absolutely. I mean, I think the sensors that you can get now, I think are, already a lot smaller than what they used to be. And I think generally, overall, I think microcontrollers and any types of electronics, I think, have this direction to becoming more integrated and, smaller. So I think the chips are smaller. I think also probably the power supplies are smaller now. And I think all of this is just leading to the same, or moving in the same direction.
And in terms of kind of understanding and I guess education on the topic of light exposure in the general community, have you seen that changing over the last few years? Do you think there is now a better understanding of what that's all about and how that might impact health?
Yeah, I mean, I think there is, I think when I started kind of in this field, I think there was much more mechanistic laboratory work. And I think the studies have moved out in the field. And with that came kind of an understanding of the real world relevance of all of this, right? So rather than talking about light exposure as this hypothetical thing that, we can control in the laboratory, I think we now have a much more developed understanding of really the importance of this stuff in the real world. Now, at the same time in the real world, of course, you have other signals as well, right? If you think about the circadian system, meal times, for example, exercise, temperature changes might even, they might even change or affect the circadian system. And I think, I think to us, of course, we think about light as one of the most important things, but in the real world setting, you have a lot more variability. I think that just comes from, of the influence of light, that just comes from other factors. But I definitely think that in the field, I think we're, there's whole conferences on the impact of light on circadian and sleep physiology, right? So it's it's definitely a big field.
Great. So switching gears a little bit to think about V3, how does mapping the V3 framework to light loggers help advance the field? Like what led you and the team to want to do this to begin with?
Yeah, I mean, I think it's sort of, if you think about it, I think there have been new sensors that have been developed, and I think it's kind of an explosion. And I think in particular, it's a very exciting time where you're thinking about, well, it's really the Wild West currently still for light sensors, right? So we need to think about what is a reasonable structure to think about what is the data that are generated from this, what is being measured. And I think this also, as kind of something that grew out of this is the work in the International Commission on Illumination is kind of, formalizing how we do these measurements. What are the key things? I think what we don't want to end up with is, a lot of data, but no way to kind of evaluate the quality of the sensor or the quality of, the metrics that are being used. I think we also have one issue here, which I think is at the same time exciting, but also a little bit daunting, which is, we have lots of machine learning techniques that you could apply on different types of sensors. And from the perspective of metrology, right, the measurement of light, it makes it quite tough to know, well, what is actually being measured, right? Because you have some raw sensor responses that are transformed in some way. And of course, this is something that, of course, we need to find a way to address. So, I think it's really what drove us to work on this is, I think there's lots of light sensors coming out. I think there's lots of evidence showing the importance of light exposure. Us realizing, well, there's a lot that I think, the V3 framework could bring to the table with when applied to light loggers and dosimeters.
Great. Well, a question from one of our online participants. Could you speak to the considerations regarding duration of recording light dosing?
Yeah, so I think there's two components in there, right? So I think when we think about dose, we typically think about time times intensity, right? So it's some type of integrated dose. I don't think we have the right metrics figured out yet. What is the right way of integrating things? I think, my view on this is light exposure might be quite variable, right? So if you are going to the office during weekdays and you go camping on the weekend, you'll have very, very different light exposures between different days and even just adjacent days, right? So that is something to consider. Typically, when we do sleep measurements with actigraphy, we have 1 or better 2 weeks, or at least 10 days or something like this, so that we at least have a knowledge of what's happening between the weekdays and the weekend. My kind of gut feeling is that it really depends on what you're trying to capture, right? So if you're kind of trying to capture, if you're just trying to measure the exposure, I think then maybe 1 week might be representative because it's just 1 week. If you want to look at long-term exposures, for example, what happens to your light exposure, over months, of course, you need to record for that time. We know that, in places off the equator, of course, we have seasons. And so day length is something that changes quite drastically. The light exposure is there's not only more light exposure, but also the maximum light exposure that you could get during the day is higher. This is just a factor that one should consider. It really depends on the hypotheses you're testing. I think light exposure in general is interesting to measure, but I think it is always integrated in some either research question or clinical question that ultimately then decides how long you should measure.
And actually, something that you just said puts another question in my mind. How important is it that you know the location of your study participants? And how specific does that need to be? The reason I'm bringing this up is I think it brings us back to the privacy issue. What if people move around between, different parts of their country or their region?
Yeah, I think this is a very, very important question. If you're thinking about, relating the light exposure someone has received to the light exposure they could have received of course, that's very specific to the geographical location. And I think this is a consideration that one would have to make, right, or think about quite carefully is, well, you know, if this is of importance to you, of course, then you have to be quite careful with privacy, because if you just had some geolocation or geotagged solar radiation data, environmental data, of course, you could figure out where someone is based, right, just by brute forcing it if you had all the data. I think there's also something that I think we should consider here, and that is so imagine you have, you're looking at, say, March and you're looking at October, the daily light exposure might be the same, but I believe there is this is belief I hold, right, is that there will be differences in your physiology coming out of winter versus coming out of summer, mostly because there's probably long-term processes that adapt to, day length. But again, I think this is something one would have to test. So even if you had a day in March or a day in October, you probably want to know, well, what is the long-term light exposure people have been getting?
Right. And you mentioned earlier the issue of adherence. I'm wondering if we can just touch on that in a bit more detail, and specifically how you handle, from a data analysis point of view, how much somebody is adherent to actually wearing the light logger, and how do you know?
Yeah, so I think there's two ways of doing this. I think in any event, you need additional data, right? And so either these data come in through additional sensors that are attached to the chip, right, or the device. And so one such sensor might be a tilt sensor. So the team in Lucerne developed a sensor that has a tilt sensor, and so you can know, is this moving or not, and are people looking at a specific, head tilt. I think the other way of doing this would be also with temperature, right? So you can imagine having, knowing is the temperature constant, or is this person actually moving around? And then finally, I think another way that we've tried was, so we used a sensor that had a magnet, and it could read, read out basically whether it was attached to a specific adapter. And so with that, we could figure out, well, which glasses were people wearing? So we had a bunch of sensors that were attached to, or a bunch of adapters that were attached to different frames, and we would know which frames people were wearing. So these are kind of, I guess, sensor augmented ways to measure compliance. I think the other way of doing this is just the old school way of what we do in actigraphy a lot is people make a log, right? They log when they're taking off a sensor, or when they're placing it in a specific stationary way. I think the problem with that is, of course, we don't know the ground truth. We kind of rely on participant reporting, the right quantity, or the right timing that they've taken it off, and we might miss times. There might be in the log some inaccuracies. So overall, it's a little bit of a trickier business, I think, than to work with these logs. Some of the sensors have buttons, right? So you could, in principle, have, a button that says, okay, I press the button now, it means I take it off. We've just been working on a device that has two buttons, right? So you can know this is on, this is I'm taking it off, this is I'm putting it on. So I think there's lots of kind of cool ways that one could use, even kind of haptic ways to interact with the sensor to make sure, yeah, I'm taking it off or not.
Right. And maybe that brings us kind of back to the earlier question around duration. Adherence to a short-term study protocol is normally quite different to adherence to a really long study protocol, especially if you're looking at seasonal changes and things like that. One more quick call out for questions from the audience, but Dr. Swichan, you mentioned the Wild West before. If you could, magically change one or two things in the next few years to move the field kind of slightly out of the Wild West, what would those things be?
I mean, I think the first thing, and this is something we've been working on in a group with the Daylight Academy, is to develop a schema for metadata. So, if you had a data set of light exposure, how would you describe this data set? What kind of sensors were used? Were they calibrated? What was the sampling duration? What kind of participant, right? So all kinds of information that one would need to know to really think about, well, is this data set useful? And so we've been working on some tools, both a descriptor, but also a tool to generate these descriptors, for data. Hopefully we'll preprint this by the end of the month. So there's a lot of kind of work making sure that we're documenting at least what we're doing. And I think the other thing, and I think this is a big drive, is really to agree on common ways to calibrate and characterize these, and also be open about limitations, right? So for different research projects, and I cannot only repeat this, I think for different research projects, you need different sensors. And this has, I think, two consequences, right? It means that there might not be the one sensor that is useful for all possible research questions, but it also means that there could be many, like the market is not saturated if you have many different sensors that could measure light, right? And I think, to me at least, the sensor is just a method, or the device is just a method. You need to bring the research question into the equation to select which sensor it is. And I think, I think it's going to be an interesting question to think about, well, which sensors would be most appropriate for which kind of study. And so I think this is where some of the structure and systematizing might be also quite helpful.
Great. Well, we are approaching the end of our time today. Just while I have a couple more slides to bring up, but just while I do that, any final comments or issues to discuss from you, Manuel?
I think it's a very exciting time, right? I think we see just a convergence of different things happening, and I think it's really, I think in working this CIE technical committee now, I really see there's a lot of interest in the light loggers, and I really think that it's a critical time now to the field. Can we bring this to the next level? Can we really make this useful for clinical and other types of research applications? So I'm very excited about it. I mentioned Wild West. I mean, I think it's sort of, I'm quite excited in the opportunities I think that the light loggers and also the standardization efforts I think will bring.
Actually, did just get one question from an online participant, which I'll switch to now. Any thoughts about approaches of giving the wearers live feedback regarding compliance or adherence? So, for example, a message to a phone saying you're moving around, but the sensor is dark. Is it covered? Is that something that you've seen in the field, or would it be useful?
Not yet, but I think it's something that we'll definitely need to work on or work on, right? I mean, I think the idea that we can have quality control through, the sensor has detected some anomaly. Now we're giving feedback to the user or the wearer, I think would be quite a nice approach. So I think there's space and opportunities there. I don't see it currently in the field because I think it's mostly research devices for now.
Right. And I guess the flip side of that is the potential changes to behavior that might result from giving that, feedback or whatever to the study participants during the study data collection period. Mm-hmm. Any other final comments? Questions from the audience? Well, thank you very much, Manuel. It's been really fascinating to learn about this, quite a different kind of biomed, I think, to what a lot of us are used to considering. Thank you again, Manuel, and thank you everyone for joining us.
Thank you so much.